categorical data. So this categorical data need to be converted to numerical value before building the prediction model. Okay. So in our data set, we are having 3 categorical data. Okay, so that may be sex, smoker, and region. These 3 columns belong to this categorical information. So this information need to be converted to numerical values. Okay, before building our model, we have to pre-process this. Okay, so how we are converting this categorical value into numerical values? We can use this encoding mechanism. So I hope till now, till that all of you completed visualization. Almost everyone has completed. Or shall I proceed to the data pre-processing? Okay, so thank you. So now we move to the data pre-processing. So we can have 2 methods. One is encoding mechanism and another one is binning mechanism is that. Okay. So encoding mechanism is mainly used for categorical values to be converted to numerical value. Suppose if the numerical, if we are having a continuous numerical value, for example, if it is like a age, if you are having a category like age, so it may be a different one. Okay, so what to say? Okay, so first come with the encoding mechanism. After that, I will tell the binning process. So we are having different types of encoding. One is label encoding, and another one is one-hot encoding. 2 encoding mechanisms now we are going to use in our data set. Okay, so first thing is label encoding. Both will do converting the categorical value to numerical value. That is the task of encoding. But label encoding, what it will do is it will assign each categorical value with a decimal number. For example, if we are having 6 male and female, then number 1 is assigned with male, number 2 is assigned with female. Like that, we can do with this label encoding. Okay, so that is for that we are using label encoder from the scikit-learn library. Okay, so there is a method label encoder which is available in the scikit-learn library. We can use it. Okay, you can see here. So from this sklearn.preprocessing, from this package, we are importing label encoder. Okay, we can directly import this label encoder. You can see the description here. It is used to encode target labels with a value between 0 and n classes minus 1. For example, here we are having only 2 6, so 0 and 1. Suppose if you are having some satisfactory level like good, better, good, excellent, very good. If it is like that, so in that cases, how many classes are there? The numbers are given from 0 to n minus 1. Okay, so you can see here we are creating label encoder for 3 things. Okay, so for the column sex, smoker, and region. Okay, so we are creating a label encoder for each thing separately. Okay, so this is the first step. We are initializing this label encoder for each column. Okay, after that, what we are doing is we have to encode this. Okay, so we are taking the column sex, data.sex. That is, we are taking that particular column and we have to use the function called fit transform. Okay, we can use this encoder, that is le_sex dot fit transform. Okay, so the fit transform, this will fit the label encoder and return encoded labels. Okay, so within this fit transform, we are giving the column which you want to encode. Okay, we are going to encode this sex column from this data set. Okay, so that we are giving, this is the label encoder name. Okay, dot fit transform is a method. So for that method, we are giving the input as the sex column. So the return result will be stored in the another column, new column, sex encoder. Okay, and similarly, we are creating another one column, smoker encoder, based on the encoded value from the column smoker. So data.smoker. And similarly for data.region. So now we are creating 3 encoded columns. Okay, you can see now the data set look like this. So these things are already there. Up to this charges, it is present in the original data set. Now we are adding 3 more columns: sex encoder, smoker encoder, region encoder. Now you can see the difference. For the category of female, this encoded value is 0. For the category of male, it is given as 1. Okay, and for the case of smoker encoder, this is also 2 option only, yes or no. So for yes, it is given as 1. For no, it is given as 0. Okay, so in the case of region encoded, you can see you are having 4 categorical values. Okay, so for example, for southwest it gives 3, southeast 2, and northwest 1. Like this, it will give 4 numbers. Okay, so this is what label encoding. Just practice this. Just execute and see. Sorry. Execute and see how it looks. What you will get the output of this label encoder. So you can see the mapping, how the values are mapped. For that only, this is the thing. That is 6-column encoding mapping. The L6 in the sense it is the label encoder value dot classes underscore. This is the value. It will return female and male. What are the things? How it is coded? That can be visualized with the help of this classes. So what are the classes we are encoding? That is female and male. No and yes. Northeast, northwest, southeast, southwest. This information, if you want, you can just print it. Otherwise, there is no need of this 4 to 5 lines. Okay, so if you see here, we have encoded this 3 columns, but you can see this region column is not binary since we are having 4 classes. Okay, so if you can see here, it does not seem like a problem, but unless the categorical value has some order, if it is an ordinal data, then binarization of categorical value is necessary because they are having some order. So if it is the data having some ordered value, then we have to do this. This categorical value should be converted to some other encoding mechanism. This label encoder is not suitable for this type of column. So for that purpose, we can use this one-hot encoding mechanism. Okay, so this is also another one encoding technique only. This is also available from scikit-learn. Okay.
And
so you can see this one-hot encoder. You can see this is the output of this one-hot encoder. Okay, so the region encoder consists of numbers from 0 to 3. That is 4 values are there. So we can't able to find out what is the meaning of this thing. So if it is binary, that is yes or no, or 2 category only, then we can easily identify. But if it is the case for more than 2, that is more than binary, then we have to come with this one-hot encoding. So you can see in this one-hot encoding, we are creating a separate column for how many regions. We are having 4 regions. So we are creating separate 4 columns. So if it is value 3, then that column alone will have the value of 1. So if it is 2, it comes to this region 2 as 1. If it is 1, region 1 is 1, all the remaining values are 0. This is what one-hot encoding. Okay, so you can see how we are implementing this. We can import this one-hot encoder from sklearn preprocessing, and first we have to initialize what we have did for label encoder. We have did this for one-hot encoder also. So after that, in the same manner, we have to use a function called fit transform. Okay, so fit transform. What is the data we are going to fit? Data.region encoded. Already we have encoded that value we have to pass. Okay, so data.region.encoded that corresponding values that should be reshaped to -1 to 1 to array. That is, we are going to reshape and convert it into array. Okay, and after that we have to convert this array to data frame, and we are adding into the existing data frame. That is, we have this 4 columns should be appended with the existing data set. So for that we are using this. We have to construct the data frame. That is data frame. This is the newly constructed this 4 columns. ARR underscore OHE underscore region, and this will be added with the column name. What is the name we are giving? Region 0, region 1, region 2, region 3. So for that we are giving the column name region underscore stri, that is string I. So from where it will take this I? This will take the I from this range of shape. So shape is, we are having 4 columns. So the I values start from 0, 1, 2, 3. Okay, so this is just for giving a name. If you want, you can simply give region 1, 2, 3. Okay, suppose if there is many number of columns, we have to take this. So this is like list comprehension. Okay, so region underscore, this will be concatenated with this number. So this str of I is denotes the number, that is 0, 1, 2, 3. Like this we can add. So we have to take this I value from shape attribute. Okay, so this is the df1 hot data frame. Okay, so the output of this df1 hot is only this 4 columns in a data frame format. Okay, after that we are going to concatenate with this original data. So pd.concat original data comma df1 hot. Okay, so we are concatenating with access 1. That is, we are concatenating it as a column. So access equal to 1. So after that we can visualize the data. So there is no error. Yes. One second, sir. Sir, I have not executed the previous cell, so that I am getting that error. So after executing this, you can see this region values are added. So now this is our original data. Okay, so now we can see in this data, we are having repeated things like sex is here also, and encoded values also, and smoker information, region information, everything is, actual data is also present, encoded data is also present. So we can remove the unnecessary columns from our data set. That is the next thing. Okay, so that is, we are dropping some of the categorical features like sex, smoker, region, and region encoded also. There is no need. We need only this 4 columns. Okay, so that is the thing we are doing here. Data.drop. We can use a function called drop to remove unnecessary columns from our data set. Okay, so after this, now we can see this is the data we are going to take for our model design. Okay, in order to train our data, we are in need of this many features. Okay, we can try. This is the pre-processed data. So from the original data, we have to take it as a pre-processed data. which consists of all the things are encoded. Okay. So till now we have completed the data pre-processing. Okay. So what are the things we needed for our model? We have to do. These tasks are not necessary. If your model needs, you can do this encoding all things. Okay. So the next thing is we have to prepare our data. That is, we have to divide our processed data into training and testing. Okay. So for that, we use the function called test train split. That is the method we can use for dividing our training data. Sorry, dividing our entire data into training set and testing set. Okay. So what we have take SQL learn that model selection input train underscore test underscore split function. So next we are using that method by passing the pre-processed data and we are taking the test sizes 0.2. That is 80-20 ratio we are going to divide. Okay. So now train and test contains train contains 80% of data and test contains 20% of the original data. Okay. So next thing is we need to divide what are all the features and what is the target data. That is the thing we are going to split. So what is the target value here? The charges is the target attribute we are going to predict. Okay. So for that now what we are doing, train underscore x. So from this x data, training data set, we are going to drop the column charges. Okay. So without charges, all the remaining things are considered as a features to be learned. Okay. So the target is the charges. So we are taking test y, train underscore y equal to train that charges that values. So train underscore x is we have to drop the column charges from that. Okay. Next thing is testing. So in the same case, we have to divide the test data into target values. Sorry, target attribute is separated and remaining things is test x. So test x is equal to we are dropping the charges column from this test data set and test y is tested at charges that values. Now we can see what is the size of this training and testing data. Training features are 1070 with 9 columns. Okay, so target is only 1 column, and similarly, testing features and testing target. So now we have prepared our data into training and testing set. We have split them and we have taken what are the features to be trained and what is the output you have to predict. We have divided in all the things. So the next task is we have to design our model. We have to build our model. So in some 2 minutes time, you all have to finish. Up to this place, everyone has to complete. Yes, everyone has completed. Yes, okay, so thank you. Yes, thank you much. So we have processed our data. Next task is we are going to build our model. Okay. So in order to build our model, we have to use the method random forest regressor. Okay, so that is available in sklearn.ensemble package. So from sklearn.ensemble, import random forest regressor. Okay. So random forest regressor and random. So in the case of random forest regressor, just we have to use that method. Simply you can use random forest regressor. All the parameters are default values it will take. Suppose if not, you can give this number of estimators. That means how many trees. So default value is 100. Okay. If you want, you can specify, or else if you just no need to give any arguments at all. Okay. So just for example, I am giving number of estimators is 7. That is number of trees. Okay. So after that, we can give this criterion. What is the measurement you are giving? Gini index or MSE anything, and maximum depth. What is the depth of your tree? How much depth you can specify? Okay. And what is the minimum sample split? That is the default values too. And minimum samples leaf. These are all the set of attributes with default values are given. Okay. So if you want to modify this default value, you have to specify, or else you can just simply give the default value. Okay. So for example, just I want to show some examples. So I am giving this number of estimators equal to 7. Or else you can just give this empty. Okay. So in random state, that is we have to ensure the randomness during the splitting as well as data selection. Okay. So that is the thing. RF underscore model equal to random forest regressor. Okay. With number of estimators. Okay. And random state I am giving. So after designing this model, you just fit with your training data. Okay. So RF underscore model dot fit of train underscore x, train underscore y. So this function will train our model. You can see here. So just it will give the model random forest regressor, bootstrap true, and what is the maximum features? It will take it as an auto, maximum leaf nodes, and all the things it will take. Okay. So what are the things we have said? That alone modified. Okay. So you can see this number of estimators and random state. Suppose if I'm not giving anything, then you can see here. So by default, it will take the number of estimators as 100. Okay. So we'll take with this 1 So we have to do this. Now we have to build our model. Okay. So after building this model, what we have to do? We have to check. That is, we have to make prediction. Okay. So with the help of the function model dot predict, we are giving we are giving the test data. That is, we are giving test x. So we are getting the output in RF underscore predict. Okay. So model dot predict with test data set we have to pass. Okay. So now we have to just take one sample and we have to check what is the value we have predicted. Okay. Now we have to check whether how the prediction is there, whether it is correct or not. Okay. We have to take one sample ID as number 7. Okay. We have to display the actual charges. That is, from the test to y, we have to take the 7th int. What is the value and what is the predicted value that we have to see. You can visualize this. Actual charges is 18,608 and the random forest prediction is 18,593.93. Okay, so almost it is nearer to our actual charges. You can just modify this number. If I'm just leaving it, how we can check how it will work. Okay, so now in this case, it construct 100 trees. So you can see here, it will get large deviation, 18,600, here 17,700. So you can set your own number of decision trees. Okay, you can try with this. In some cases, the prediction is like this. We can check with this some other sample. Okay. We are having 268 testing data. So in that case, we can give this 2 months and we can check. So this is also large deviation because I need to execute this. So model design is just a trial and error. In which case you will get a best results and that number of trees you can fix it. So here it is even for the number of estimators 7 also, this is very large difference, actual charges in this. In this sample, it is nearer to the given predicted value. With some other samples, it will give a different results. Okay, if you try with some number of trees, you can modify a layer and score, then you can see how the prediction will happen. So if you take it as a number of trees is 50, you can see these values are more near 18,608 here, 18,088. Okay, so this is the case for we are checking with some single prediction value. So finally, we need to find out the accuracy, how much the model is accurate. So for that, we have to evaluate. Okay, so for that evaluation, we can use this metrics called mean squared error and R2 score. Okay, MSE and R2 score, this is the metrics evaluation for prediction model. When you are using regression model, you can evaluate the performance with the help of these two measures. MSE denotes the average squared difference between predicted and actual values. That is the mean squared error. Okay, and R2 score, that is the coefficient of determination. It is a regression score function. Okay, we can execute this. That is from SQL and metrics, we are importing mean squared error and R2 score. Just you have to call that, that's all. So RF underscore MSE equal to mean squared error of, what are the arguments you have to pass? Test Y value and predicted value. That is the actual results and the predicted results. Based on this, it will find out the MSE value. That is mean square error value. You will get the mean square error value as 4957. Okay, and similarly, we can find out the R2 score using the method R2 score of test Y comma predict. So we are getting the value is 0.82. That is the R2 score value of this model. Okay, so this is the, if you are using a classification, then you can use the confusion matrix and classification report. So, but if you are using a regression model, you can use this mean square error or root mean square error, RMSE. You can use any of the measures to find out. Okay, so if you are using multiple regression model, like you can compare with the linear regression model or logistic regression model, you can find which one produces better results. That model also you can try. Okay, so it's model evaluation now. So this is for evaluating how our model works. So for this data set also, if you try with the linear regression model, you can see this random forest performs better when compared to the linear regression. This is a simple example. If you take linear regression model, then you can compare how it works and all the things. Just you can try with this evaluation. We can see how to visualize this random forest. In the last session, you can visualize a decision tree. In a similar manner, you can visualize here also. So in this case, we can take one decision tree as a sample from this random forest. Suppose if you are generating 1,000 trees or 100 trees, in that we can take only a single decision tree, and I will show how to take this and how to visualize it. Shall we move to the next one? So this is for testing. This is almost, you can use the same thing with all the regression models. Okay. So suppose if you want to find the statistics of your random forest, that is how many number of nodes, what is the maximum depth, all the things you can see, you can find out. Okay, so how we are going to take that information is, we are having this, we are designing a model, RF underscore model. So that the model has one parameter called estimators. So RF underscore model dot estimators are that. So from this estimators, we can identify how many nodes are there, what is the maximum depth of a tree, all the things we can find out. Okay, you can see, yeah, just for reference, we are taking number of nodes and maximum depth as a empty list. Okay, so and we are taking for index tree in RF underscore model dot estimators. Okay, so from this model estimators, this estimator will give a single tree. Okay, so that I will show you next. So in this, we are taking this index tree underscore dot node count. So on each node, we are counting, and the nodes are appended to this n nodes. Okay, and similarly, for each tree node, we have to find the maximum depth. That is also listed here. Okay, so we have to find the average number of nodes. So np dot mean of n nodes and np dot mean of max depths. Okay, so this will give the statistical information about how many number of nodes on an average is present, and how many, what is the maximum depth, what is the average depth. So here the maximum depth is 80 and the average number of nodes is 1348. For a single tree, we are taking the trees. So this will take each one by tree one. Okay, suppose if you are having 50 trees, so it will take one by one each tree and finding what is the node count, what is the maximum depth. For example, 5 trees, the node contains number of nodes present in each 5 tree and the maximum depth of the each 5 tree. So for that, it will find the means. So suppose if you want to see what is the content present in n underscore nodes, you can see. You can see. So the first tree contains 1369 nodes. Second tree contains 1367, 1355. Like this, you are having, we are constructing 50 trees now. So 50 entries are present in this node. And similarly, we can visualize this maximum depth for each trees. What is the maximum depth value? So first tree 18. For one tree, we are having 16. Okay, so like this, we can find out the individual tree data and average data from this information. Okay, so this is some statistic information about the trees present in the random forest, and I will show how visualization of one decision tree in the random forest. Okay. So this is the thing. The same thing what you have used for visualizing decision tree. The same thing, but what we are doing is we can take this sklearn.tree import export graph list. This is for visualization tool. Okay, and we are importing pi.1 package. We are taking only one tree. That is, pull out one tree from the random forest. RF underscore model dot estimator underscore 6. That is, we are taking the seventh tree. Okay, so it's from 0. So I'm giving 6. That is 7th tree we are taking. Okay, and we are exporting the image to a dot file. That is, export graph list method will take you to export a decision tree in dot format. Okay, so after that, what we are doing is we have to use this dot file to create a graph. That is, we are taking the function pi dot graph from dot file. Okay, this is this tree dot contains the dot information about this image. So from this dot file, we are going to construct a graph. So for that graph from dot file we are using, that is available in graph. So we are writing this graph into one file. That is tree.png we are writing. Okay, so this tree.png is available in your Google-colab, Google Drive. Okay, so now what we have to do is we need to visualize now. So for that we can do this from Google-colab patches import cv2 underscore im. This is a function to show the image. So from that we are reading this file. reading this image. That is /content/tree.png. So tree.png அப்படின்ற அந்த இமேஜ் வந்து கண்டென்ட் ஃபோல்டர் வந்து நம்ம டிரைவ்ல இருக்குது. அது வந்து நம்ம எடுத்துக்கோம். Okay. So you can see this is the image to show. Just a minute. So you can't able to visualize because it is like this. Just a minute, I will share another one screen. Okay. Maybe. So you can see, okay, I'm able to see. So this is one of the decision tree present in the random forest. Actually, you can see this much long tree. So this time zoom in. So that's why you can't able to see this in Google-colab. You can see first starting with this smoker encoded value. What is the mean square error? What is the samples? How many samples are there? What is the value? Okay. So from this we are taking another 2 childs. Okay. So the first case is if it is true. So smoker case is true. Then next we are taking this age as a parameter. Okay. And next children. So in this case you can see the depth. What we have identified that the depth is 16, 18 for each node. We can have that many depth. Okay. So if you want, you can visualize entire tree. Okay. So for each thing, the parameters are taken as chosen. Here it will chosen age, again sex, region, again region, children. In that manner, it will take it. Okay. So just I will share the code for generating this tree. So in this code, you can see this. We are having a feature list. The variable is there. You can see here feature names. That is, we have to name this. So for that, you can use this line. Then only you can able to get the output. So if you want to import this data, sorry, if you want to visualize in Google-colab itself, you can use this commands cv2. Okay. If not, if you want to download this, you can use this. That is Google.colab input files.download. From where you are going to download. That is, it is available in the folder /content. So I am giving /content/ the file name I have used for writing. Okay. So this function will show here. You can't able to view this image, so that's why I'm downloading this. So using the function files.download, from where you are downloading your file. So how can we upload a file? Similarly, we can be able to download this. Okay. So this is a example for random forest. I hope you have some idea with this random forest implementation in Python using scikit-learn. So if you are having any doubts, you can ask. You can just execute this code and you can visualize. If you modify this line, you can see different thing. Now I'm giving 6 instead of 6. If you give some other value, you can visualize another tree. You can compare both the trees, how it works, how it is constructed, all the things you can visualize. Participants, if you have any doubts, you can ask about this coding or random forest. Next, we will have another one session. Mr. Valaganesha will continue the session on next machine learning algorithms. If you have any doubts, you can ask. I will start my presentation. Karthikeyan sir?
Yeah, yes, madam. Yes, madam. Yeah, the next session will be handled by Mr. Vale Ganesh about k-means clustering. Vale Ganesh, sir, over to you. You can take the session.
Good evening, all of you. I hope my audio is.
Yes, sir.
I am audible.
It is audible, sir.
Okay. So, good evening, participants. So, the topic for today's presentation is k-means clustering. So, it comes under unsupervised learning. So, what you are seeing so far is all about supervised learning. So, my name is Vale Ganesh. I'm from Mechanical Engineering, working as an assistant professor in Ramco Institute of Technology for the past 5 years. So first and foremost thing of this presentation is I would like to give a high-level introduction to clustering, its applications, and different types of clustering algorithms available. And since my topic is limited to k-means, second portion is about what is meant by k-means, their introduction, then procedure to apply that algorithm. Then we are going to see a demo using Google-colab. So clustering for segmentation. So customer segmentation is the practice of partitioning a customer base into groups of individuals that have similar characteristics. For example, one group might contain customers who are high profit and low risk. So they are more preferable to purchase our product or subscribe a service. Knowing this information allows a business to devote more time and attention to retain these customers. Another group might include customers from non-profit organizations and so on. A general segmentation process is not usually feasible for large volumes of data. Therefore, you need an analytical approach to deriving these segments and group of large base data. So this is called as a clustering. So first of all, we need to read out the data carefully, and we are going to apply certain kind of clustering techniques. So customers can be grouped based on several factors like their age, their education, their interests, spending habits, and so on. The important requirement is to use the available data to understand and identify how customers are similar to each other. So that is the main criteria behind this. Let's learn how to divide a set of customers into categories based on characters they share. So in this picture, you might be able to see there are 3 different type of categories. One is cluster 1, second one is cluster 2, and third one is cluster 3. Cluster 1 is indicated in light blue color. So they are all called as affluent and middle-aged peoples. Cluster 2 is all about young, educated, and middle-income people. Cluster 3 is talking about young and low-income people. So this is the data that we can able to get it from a sample data set. After clustering, then the corresponding customer ID and their segment could be divided like this. The same could be adopted in their data set too. Yeah. Now, what is meant by clustering first? So clustering is nothing but a group of objects so that are similar to other object in the cluster and dissimilar to data point in their cluster. So as you can see in this scatter diagram, there are a lot of points are available that could be clustered based upon the similarity available. Clustering versus classification. So this is the next important thing. Clustering is little difficult or little different from classification. Let's look at our data set again. Classification algorithms predict to classification algorithms is to predict classified labels. For example, here the labels are like this. The means assigning instances to predefined classes such as defaulted or non-defaulted. So generally speaking, classification is a supervised learning where each trained data instances belongs to a particular category or classes. For example, in clustering, however, the data is unlabeled and the process is unsupervised. So here you can able to see here classification modeling could be done with the help of decision tree model, and unlabeled data set unsupervised learning we can able to do clustering with the help of k-means model. We can use a clustering algorithm such as k-means or hierarchical to group similar customers as mentioned and assign them into a cluster based on whether they share similar attributes such as age, education, income, and their spending habits. So next thing is I would like to talk about applications. First thing is retail marketing. Clustering is used to find associations among customers based on their demographic characteristics and use that information to identify buying patterns of customers. And secondary thing is recommending new books to find a group of similar items or similar users and use it for collaborative filtering to recommend things like books or movies to the customers. Second thing is banking. In banking sector, analysts find clusters of normal transactions to find out the patterns of fraudulent credit card usages. Also, they use clusters to identify the type of customers like loyal and versus shunned customers. Third category is about insurance. In insurance sector, clustering is used for fraud detection in claim analysis and to evaluate the insurance risk of certain customers based on their segments. Fourth one is about publication. Clustering is used for auto-categorize news based on the content. Then cluster is to recommend similar news articles. In medicine sector, it is mainly useful for characterizing patient behavior based on similar attributes. Next one is in biology. This clustering technique is used to identify the different types of illness, and it is used for group genes with similar expressions, patterns, or to cluster genetic markers to identify family traits. Why clustering? Why should we go for clustering? So these are all the 5 parameters. So that gives a proper explanation of clustering. One is exploratory data analysis. Second one is summary generation. Third one is outlier reduction, that is fraud detection or noise reduction. Fourth one is finding duplicates. And fifth one is pre-processing step. Next one is classifications. One is partition-based clustering. So this is relatively efficient. Example, K-means clustering, K-median clustering, fuzzy Z-means. And second one is hierarchical clustering, produces tree for clusters. Example, agglomerative and divisive. Third one is density-based clustering. So it produces an elliptical shape, produces arbitrary shaped clusters. Example, DP scan. These are all the 3 different clustering, 3 different types of clustering available in this market. Yeah, next we move on to the K-means clustering. Imagine that would have a customer data set and you need to apply customer segmentation on this historical data. So customer segmentation is the practice of partitioning a customer base into groups of individuals that have similar characteristics. The various features are age, education, income, their spending habits, their addresses, and debit into income ratio. So one of the algorithms that can be used for customer segmentation is K-means clustering. So it comes under partition clustering. K-means divides the data into non-overlapping subset that is called as clusters without any cluster internal structure. So here examples within cluster are very much similar. Future example across different clusters are very different. As you can see, the 3 different groups are indicated here. Within the boundary, it look like same, and outside the boundary, it might be different. Next thing is how to determine the similarity or dissimilarity. So indeed, the similarity measure highly controls how the clusters are formed. So it is recommended to understand the domain knowledge of your data set and the data type along with futures, and then choose the meaningful distance measurement. You can form the similarity matrix based on the 3 group of clusters. Next thing is dissimilarity. So this could be done with the help of 2 parameters, that is distance measurement. One is intra-clusters and another one is inter-cluster. Intra-cluster distances are minimized in order to form a cluster, and inter-cluster distances are to be maximized in order to differentiate each other. So take a look at the example for a single dimension or one dimensional similarity. Here customer 1 and customer 2 is indicated in this picture, and the only one feature is age. Customer 1 age is 54 and customer 2 age is 50. Whether they are similar to each other, that could be calculated with the help of Euclidean distance formula. That distance x1 and x2, which is equal to square root of x1i minus x2i the whole square. We can able to compute this if the distances are relatively too small, means they are belongs to the same category. If the distances are maximum, means they are interclusters. Next thing is we are going to add another dimension that is called as income. In previous slide, we discussed only about the age. Here we are going to add one more feature like income. So here again, the formula could be the same. We can able to see the distances once again with the help of the few features like age and income. Similarly, we can able to compare in multi-dimensional by adding another features like education, their income, their spending habits, like so on. So how does K-means clusters work? So that could be seen in the upcoming slide. So the first and foremost step is we have to initialize the K. In this picture, you may able to see there are 3 different clusters are available. That is indicated in the square red color dot. That is indicated in the square red color dot. The scatters are produced based on the various features, and the x-axis depicts the income and the y-axis depicts the age of the customers. So in this example, I would like to initialize the K value with 3 different clusters are formed. Essentially, determining the number of clusters in a data set or K is a hard problem in K-means. There are 2 approaches to choose these centroids. One, we can randomly choose 3 observations out of data set, and these observations are the initial parameters. We can assign this as the initial parameter only. And the secondary one is we can create 3 random points, which is shown in this picture, as a centroids of this clusters, which is our choice, that is shown in the plot with the red color. Their corresponding centroid value is here. For example, C1 is 8 dot, 5 dot, in x-axis 8 dot, y-axis is 5 dot. This is the mean value of the cluster. C2 is 5 dot, 5 dot. It is available here, and C3 is 6 dot, 3 dot. And the secondary step is distance calculation. So after the initialization step, that is defining the number of cluster is over, next thing is we have to assign each customer to the closest center. For this purpose, we have to calculate the distance of the each data point, or in our case, each customer from the centroid points. As mentioned before, depending upon the nature of the data and the purpose of which clustering is being used, different measures of distance may be used to place items into the clusters. Therefore, you will form a matrix. Each row represent here represent the distance of a customer from each centroid. It is called as a distance matrix. The main objective of k-means clustering is to minimize the distance of data points from the centroid of the cluster and maximize the distance from the cluster from other centroids. So in this step, we have to find the closest centroid. To each data point. We can use the distance matrix to find the nearest centroid to the data points. With the help of this matrix, we can able to find the corresponding value. So finding the closest centroid for each data point, we assign each data point to that cluster. In other words, all the customers will fall to a cluster based on their distance from centroids. We can easily say that it does not result in good clusters because centroids were chosen randomly from the first. Indeed, the model would have high amount of error. The error is the total distance of each point from its centroid. So here, sum of square method is used to find the amount of error. So initiatively, we try to reduce the error. It means we should shape the clusters in such a way that the total distance of all members of a cluster from its centroid to be minimized. Now the question is that how can we turn it into a better clusters with less error? Then the obvious solution will be we have to move the centroid from one location from the another. Yeah. Now, as you can see, the centroid could be moved here based upon the mean value of the nearest data point, based on the mean value. For example, centroid 1 having five similar type of customer IDs. So this point could be moved. Initially, this point is placed here and moved here based upon the mean value of all these points. Yeah. As you can see, the centroid 2 is moving here. A point coordinate is 7.4, 3.6, and B point coordinate is 7.8, 3.8. The mean value of these two points are 7.6 in X dimension and 3.8 in Y dimension, 3.7 in Y dimension. Now the corresponding centroid has to move close to those data points. So this is the last step of k-means clustering. K-means is an iterative algorithm, and we have to repeat the step number 2 to step number 4, which is discussed earlier. So in each iteration, it will move the centroids and calculate the distance from new centroids and assign the data points to its nearest centroid. It results in the clusters with a minimum error and more dense clusters. So this is one of the inherent advantages of k-means clustering. Initially, all the center points are initially we assigned with the 3 center points. That 3 center points is placed here. Now, after having each iteration, these points are moving closest to each other based upon the minimum distance between the points and its centroids. Sum of square error is used for minimizing the amount of error present in this clustering technique. However, as it is a heuristic algorithm, there is no guarantee that it will converge to the global optimum. This means the randomized starting centroid, it may give a better outcome. As the algorithm is usually very fast, it won't be any problem to run it on multiple number of times. So this is a simple recap what I told earlier relevant to the K-means clustering algorithm. So the first step is we have to randomly choosing K-centroid, that is one for each cluster. And secondary thing is calculate the distance of each point from each centroid. And third one is assign each data point to its closest centroid in order to create a cluster. And the fourth point is recalculate the position of the K centroid. And step number 2 to step number 4, we have to repeat until otherwise the centroid has no longer moved. So these are all the 5 steps we need to do while doing some work relevant to K-means clustering. I hope you may able to have an idea relevant to K-means clustering. What is actually clustering is? Clustering is nothing but a group of points having similar characteristics. So there are 3 types of clusterings are available, out of which I am going to talk about only partition clustering. So partition clustering, in partition clustering, I am only talking about the K-mean clustering, how to identify the similar or dissimilar object that we discussed here. And we discussed with a couple of examples like one-dimensional similarity and the two-dimensional similarity and multi-dimensional similarity. If the data is too large, means we can able to see the larger amount of scatter points. Then the steps to be followed while implementing K-means clustering. Now the question is, how can we evaluate the goodness of the clusters formed by K-means? In other words, how do we calculate the accuracy of K-means clustering? There are 2 ways are possible, which is shown in this slide. One is external approach and another one is internal approach. So the external approach is to compare the clusters with ground truth if it is available. However, because K-means is an unsupervised learning, we usually don't have ground truth in real world problems to be used. But there is still a way to do to say how bad each cluster is based on the objective of the K-means. Also, average the distance between the data points within the cluster can be used as a metric of error for the clustering algorithm. And the next step is how to choose the number of K or number of clusters. So determining the number of clusters in a data set or K value in the K-means algorithm is the frequent problem in the data clustering operation. The correct choice of K is often ambiguous because it is very dependent on the shape and the scale of the distribution of the points in a data set. So there are some approaches to address this problem, but one of the technique that is commonly used is to run the clustering across the different values of K and look at the metric accuracy for the clustering. So this means we can able to see the distance between the data points and their cluster centroid, which indicate how dense our clusters are to or what extent we can minimize the error in the clustering. Then look at the change of this metric, we can find the best value of K. But the problem is increasing the number of clusters, the distance of the centroids to data points will always to be reduced. This means increasing K tends to decrease the error or reducing the error. So the value of the metric as a function of k is plotted, and the elbow point is determined where the rate of decrease is sharply shift here. So it is the right for the clustering. So elbow point is one of the method to determine the number of cluster requires. So k means is a function on medium and large size data set produces sphere-like clusters because the clusters are shaped around the centroids. And the third one, its a drawback is that we should pre-specify the number of clusters, and this is not an easy task. So these are all the things or theory behind in k-means clustering. So it comes under unsupervised learning. So clustering is the main technique behind in this work. So there are 3 different types of clustering available in the market. One is partition based, the another one is hierarchical, and third one is density based clustering. So out of which I would like to talk only about k-means clustering. Next thing is the procedure, which is already detailed described earlier. Now we move on to the hands-on session using collaborator. Yeah. So in this hands-on, I would like to show 2 different programs. One is applying k-means in a randomly generated data set, and second one is with the help of one comma separated value file, we are going to apply the k-means for customer segmentation. So what I was shown in the presentation earlier, it's a customer segmentation operation, so that could be detailed with the help of this Google-colab laboratory. And first thing is I'm going to apply k-means on a randomly generated data set. So this is the first step, and the secondary thing is customer segmentation with the k-means. So there are 2 different programs are involved in this collaboratory file. Okay. The first step is I would like to import a couple of libraries like random, numpy as np, and for showing some graph, matplotlib.pyplot as plot, and from sklearn.clusters, scikit-learn or sklearn, it's a machine learning library, normally provides some applications like classification, regression, or cluster-based applications. I have to import the k-mean algorithm. And next thing is from sklearn.dataset.samples_generator, I have to import make blobs, and matplotlib inline is provided in the last line. So this is the library I would like to call on the first step of my work. So the same could be pasted in the chat box. You are also requested to do the same kind of work. So next thing is np.random.save. I would like to know the status of the random as a random thing. So I would like to play here also. I think it might produce some error because I forgot to click play on the first cell. While running it on a first time in Google-colab, it will take some amount of time to connect it into your Docker. Yeah, it's the expected one. Since I forgot to click play button on the first cell, now the libraries are called. Now it won't produce any error. Okay. So here I would like to take a 3 parameter. One is number of samples I would like to take. That is the sample values around 5,000. And the centers, I'm going to choose 4 clusters, and for each cluster, the centroid or center value will be one cluster 4,4. Another one is -2,1. Third one is 2,-3, and fourth one is 1,1. So I'm going to call 4 clusters k equal to 4, and for each cluster the center value will be like this, and the standard deviation value is 0.9. The output may be in the form of graph. So it contains 2 dimensions. One is x and another one is y. X generate shows the number of samples, and y will provides the cluster membership of each sample. And the next thing is, so I would like to paste it parallelly in order to have proper hands-on. So this is the third step. I hope you are all following me, right? The third step is calling the output parameters x, y, which is equal to make_blocks. Number of sample is 5,000, which I already described earlier from the blocks, and centers equal to the 4 cluster points value. Initial centroid value is 4,4, -2,1, 2,-3, and 1,1, and standard deviation is around 0.9. So this could be properly defined in order to plot a scatter plot in the next cell. Yeah. Now the plot has been created based upon the 4 different types of clusters. As you can see, 4 different types of clusters are formed based on the 5,000 number of samples. Next thing, we are going to call or configure the k-means according to our parameters. Then one is k-means equal to k-means initialization of k-means plus number of cluster equal to 4, and initialization is 12. So this is the next step we need to do it. Next thing, we need to check the fit. Yeah, it provides algorithm auto copy underscore x is true. Initialization of k means plus, and the maximum iteration is 300. As I already told earlier, it's the fastest one, so no need to worry about the number of iterations. Normally it is 300. Number of clusters equal to 4, initialization is around 12, and the jobs is none. Pre-compute distance is enabled as auto, random underscore state is none, and the corresponding tolerance and verbose is given here. Now I'm going to call or save it as another parameter, that is k underscore means underscore label, that could be equivalent to k underscore means dot labels. So this is the thing which I would like to do in the next step. Again, the same thing along with their centers are also has been saved into the another parameter. Yeah, so this is the step which we would like to do. So this is for creating the visual plot. This is the thing we would like to do. So here we have to create the plot with the dimension figure equal to plt dot figure. The figure size is x in 6 and y is 4, and we have to apply some color in order to differentiate the different forms of clusters. And the next thing is Again, we are going to create some subplot with 1, 1, 1. So all those things are given here. Yeah. So after finishing all those things, those 5,000 samples has been differentiated with 4 different types of categories or 4 different types of clusters. As you can see, this is number 1, this is number 2 or K2, this is K3, and this is called as K4. Initially, the plot will be look like this. After applying some K means, now this could be shown like this. I'm going to copy this. Randomly generated data set. This is not a proper way to apply it. This is just for an example only. We can take this randomly generated data set from sklan or scikit library. We are going to call make underscore blobs. So 5,000 samples are here. It could be turned out into 4 number of clusters. The same could be experienced into 3 number of clusters, so that we can able to practice it here. Yeah. Next, to move on to the second program. Second program is customer segmentation, which I already detailed in the presentation. So this presentation is shows about the customer segmentation. So it is started with the segmentation operation. Okay. So this is going to be experienced here. First thing is we have to download the customer segmentation. So that is the first step. wget -4 customer underscore segmentation.csv. So this could be downloaded from the yeah, 100% is over. After if it is downloaded, it will be automatically shown on this model tree customer underscore segmentation.csv. So this is the file name we have given here. Now we can download it with the help of download option, and we can able to see what are all the data available in this CSV file. It will take some amount of time. Now for you are all requested to download. In Deepali Patil, there is no code after that. The first program is over. First program is just applying K means for a randomly generated data set. I think this one not showing the cluster. Once again, I will check. I think I tested everything. Please wait for a while. I think the complete code is not pasted there. I will paste it one by one in order to have a proper visualization. I will use my system to do this. Okay. First, paste it up to this. Since it is a larger cell, so all those data are not copied, so you won't get any plot, I think so. since it is a very basic thing for Matplotlib, so that I can't able to explain it one by one. All those things are very easier one. The corresponding label or tag is provided here. Now you can copy all those things starting from initialize the plot starting from here. Plot with the specific dimensions, you can able to see the corresponding visualization or scatter plot with various forms of clusters. Yes, thank you. Shall I move on to the second one? Okay. So second one is customer segmentation operation. We can get the comma separated value file from this URL. So once again, I will post it in the chat box. So this is for customer segmentation operation. If you open that file provides the following details. One is customer ID, second one is age, third one is education, fourth one is years employed, fifth one is their income, and card transaction and other transaction values are provided here. Their defaulted values along with their addresses, then debit income ratio is provided in this comma separated value file. So next thing is I have to load this CSV file for my work. For that I am going to call pandas as PD. So next thing is I am going to create a data frame, customer underscore data frame, which is equal to pandas dot that is PD dot read underscore CSV. That file could be the file name could be placed here. Then I am going to call the head only. That is the first five rows are provided here. That is starting from 0 to 4. So the details which is available in that CSV file that could be detailed here. So I'm going to copy and paste it here. And next step is after loading the data or customer segmentation file into in our work, next thing is we are going to pre-processing it. Okay, we are going to pre-processing it. So in this data, address is not required since they are all from various demographic region. So I am going to drop the address from this CSV file. So that could be removed df data frame equal to customer underscore df, which is defined here. Could be removed in one axis and the df dot head. Now you can see after defaulted column, debit income ratio will be appeared here, and the address column could be removed or could be dropped. So I'm going to paste this once again. So after dropping certain irrelevant future, next step is you are going for normalizing the work. So again, from skline dot pre-processing, you are going to import standard scalar. So x data frame values will be provided here, and x equal to nb dot nan to underscore num underscore x, and the corresponding standard scalar and the fit transform values are provided here. As you can see, now the array will be created based on this number of cells are available in the data set. So this is the normalizing operation. So this is the code for normalizing thing. Yeah. Next step is to create a model. So I'm going to create the number of clusters as 3. Earlier it was 4. Now I'm going for number of clusters as 3. Again, k means could be initialized to the same step what we discussed earlier. K underscore means equal to k means initialization of k means plus plus. Number of clusters equal to cluster num. Cluster num is 3 is provided here, and the initialization is 12. And the k means dot fit x labels could be provided here, and we are going to print those labels. So as you can see, there are 3 labels are provided. One is 0, another one is 1, and another one is 2. So the corresponding values are generated. The corresponding values are generated here for that CSV file. So next thing is plus underscore km, that label would be assigned in each row in the data frame. Now you can able to see plus underscore km is provided here with the values of with the 3 number of clusters 0, 1 or 2. For example, as you can see, the customer ID 1, 3 and 4, their distances are moreover similar, so they are all belongs to the same number of clusters. They are all belongs to the same number of clusters, and customer ID 5 and customer ID 2, they are all different from customer ID 1, 3 and 4. Now we are going to calculate the mean value of each clusters. Yeah. So cluster 0, customer ID, the total number of the mean value of the customer ID is 432, and for first cluster the mean value is 410, and the second cluster the mean value is around 402. So these are all the mean values of all those features like customer ID, their age, their education, their years employed, their income level, their debit with respect to card and other transactions, their defaulted value and debit income ratio values. So this is the centroid values actually. Next thing, we are going to look at the distribution of customers based on their age and income alone. So we are going to see the distribution of customers with respect to age as well as income. Okay, so the graph would be plotted with the x-axis in terms of age and in y-axis in terms of income. Their font size and other parameters are provided here. Now you can able to see x-axis depicts the age and y-axis depicts the income. There are 3 different clusters are formed. One is with violet color, and another one is with yellow color, and third one is with some blue color. Okay, so these are all the distribution of customers. And the final step is, in order to visualize this in 3 dimension, this command could be utilized from mpl underscore toolkits.mplot3d. We are going to import access 3d. So from that we are going to give some initial parameters. Figure equal to plot.figure. Figure number is 1 and figure dimensional size is in x-axis 8,6, and the plt.clf is provided here, and their corresponding elevation azimuth values are provided here. X label is all about education, Y label is about in age, and Z label is about income. So I'm going to just run over through it. Now you can able to see. So this is education. This way it is education, that is X. In Y it is age, and in third dimension Z is in terms of income. So the corresponding scatters are plotted. So as we can able to see, there are 3 different clusters are provided here. So one is the affluent, educated, and old age, and the second one is middle aged and middle income, and third one is young and low income. Okay, which is already discussed in this presentation. So 3 clusters are formed. Cluster 1 is about affiliated and middle age, and cluster 2 is about young, educated, and middle income, and cluster 3 is all about young and low income. So 3 different clusters are formed here in 3 dimension. So this is the last part of this gaming's hands-on session. Now come back to the references. So these are all the references that I refer while preparing this presentation. One is IBM cognitive classes for hands-on session, and GitHub repository for K-means algorithm from scratch. Tutorials point towards data science and analytics Vidya. So thanks for attending. So if you're having any doubts, please ask, and post your comments in aresearch@ratofratjpm.ac.in for further postings. So that's it from my presentation. Thanks for attending my session. So wish you all a advance Happy New Year.
Participants, if you have any doubts, you can ask. And as Balagane said, Happy New Year to one and all. On 2nd January, we will meet again for our sessions. Yeah, thank you. Thank you very much.
Yeah, feedback link will be posted here. I will post the feedback link.
Madam Tara, madam, what is the problem? Actually, we worked out a few people that have joined also. You are not able to join? May I know what is the problem, what it says? Okay, we will check it, madam.
Ma'am, please post your email ID in the chat box such a way that we can able to give the invitation from our side for Google Class.
Subhashini ma'am, if time permits, we will do it anaconda also. Anaconda distribution also we will do.